I'm going to talk about our project, which is called MIXSEL, and it is about vertical integration of ultrafast semiconductor lasers for wafer-scale mass production. So, why do we want ultrafast lasers? Ultrafast lasers generate very well-controlled flashes of light with picosecond or femtosecond duration. So, nanosecond for us is not ultrafast. And with such pulses, we can access ultra-short timescales and observe very fast dynamics. Ahmed Zewail could show in 1994 that he can use femtosecond pulses to understand the dynamics of chemical reactions. So you ask what will happen during a chemical reaction, which transition states will be occupied, and you can have an answer to this by using femtosecond pulses. And this groundbreaking work was later then honored with a Nobel Prize. So I hope I could convince you that it's good to have fast pulses, not only to understand fast dynamics, but it's also important for using them. And one area which here for the Nano-Tera community will be interesting is fast communication. Using short pulses, in this case with picosecond duration for example, optical interconnects or for optical clocking. So we already heard this morning that interconnects, electrical interconnects, are a challenging problem in terms of heat. The current ultrafast lasers are pretty bulk, complex, and not really reliable. So here you can see an image of a titanium sapphire laser, which is used in real world, in biomedical labs. We had one of those at Sony, but we never would have thought to use this in a mass production. And this is because you have many different components. You have a laser glass, you have different, pump mirrors and so on. So it's a rather complex situation, about a meter. And we think that the way to go, if you want to have practicable ultrafast sources, is to go for semiconductor lasers. And this is because in the continuous wave regime, this has already been achieved. Semiconductor lasers are in many different devices. So, for example, in CD players. And if you drop your CD player and it doesn't work anymore, usually it's not because the laser inside there is dead. If you drop this laser, I'm pretty sure that it will be hard to recover it. And our approach is to use vertical emitting semiconductor lasers, because the continuous wave lasers that currently have a large success are mostly based on edge emitters. So the light propagates in the epitaxial layers. And here we are going then for vertical emitters, and we use semiconductor saturable absorbers for passive pulse formation. And this can be now integrated into a single device, the MIXSEL.